we come to our third speaker this morning, who's again going to address some of the challenges that we see in verification. Matt Graham is from Cadence Design Systems, who's one of our sponsors today. He's the project engineering group director, focused on automation and AI solutions in system verification group at Cadence. Matt started his career as design and verification engineer in Canada and at the US before joining Cadence almost 20 years ago. During his tenure at Cadence, Matt has held several application engineering and production roles in Canada, the US, and most recently based out of the Cadence International Headquarters in Cork, in Ireland. Over to you, Matt. Thank you.
Thanks, Mike. Two thank yous to give before I start. First of all, our sponsorship has been driven here for a number of years at Verification Futures by Michael O'Sullivan, Michael's here. Put your hand up, Michael. So he's all the way in the back. So everybody come say thank you to Michael. Michael likes to talk to everybody, and maybe he'll try and sell you something too. And then the second thing, thanks to Francois and Mike for scheduling Francois just before me, because you've given me a perfect lead in. So thank you very much. One last pitch or plug for Cadence while I'm standing up here. We're doing our best to make verification cool. We've recently, probably many of you seen, we sponsored McLaren Formula One, maybe not as far up the grid as we'd like them to be, but maybe they'll use some of our software and get a little bit further up. But that's been the best thing for recruiting that we've ever done. We rock up to a university event with a load of McLaren hats, and all of a sudden everybody gets very excited. So we'll challenge all of you, find something. It doesn't have to be Formula One, but something that can get students excited. I think it really made a big difference for us. And leading with a beautiful segue. Again, thank you, Francois, for the lead in. Of course, you know, it goes without saying verification is getting harder, but in addition to verification getting harder, and we won't quote Moore's law or any of the other things that people usually talk about in this area, but something that stood out for me is that we're looking at, I'm pointing the wrong way, we're looking at something like 4x the number of annual design starts over the next decade, according to whatever this IBF's global semiconductor. And I think anecdotally, when I go visit customers, every one of them, you know, 3 years ago we did 1 chip a year. Now we're doing 4 chips a year, or 5 or 6. We did 2, and now we're doing 10. And when we ask, well, you know, so are you multiplying your engineering talent by 2, 3, 4, 5? And of course they say no. They don't have the budget for one, and the engineering talent may or may not exist. So all of you students that are here, it's a great time for you to be getting into microelectronics and verification. But obviously that's not going to be enough, right? We still, even if we find what was it Francois said, 150,000 verification engineers we need over the next however many years, 5 or 10 years, that's still not enough to keep up with the level of complexity and the number of design starts. You know, our first speaker from ARM was talking about the number of ICs in a car. That's going to continue to increase. The ICs in everything from your toaster to your refrigerator to your mobile phone to whatever is going to grow. And that's, you know, there's no question whatsoever about that. The main question and one of the key things that we think can help address this is, of course, AI. And AI is just the latest along this kind of line of I don't know if you want to call it development or evolution of humans, or evolution of what we can do as humans. But you see, you know, for you know, a long period of time, we relied on, you know, our own muscle power, and then we started to move into sort of the Enlightenment, sort of leverage our brain power. And then it's at the dawn of the Industrial Revolution, of course, we morphed that into machine power. And we're seeing now, you know, as we accelerate faster and faster into the area of AI, that we're now able to leverage not only the machine muscle power, but the machine brain power, and do interesting things with it. And again, thanks to a great lead-in from Francois, he said, I don't know what AI is going to do, but I feel like it's going to do something. Well, hopefully today, when my talk and some of others, we can start to give some bounce to that and figure out, well, what can we do with AI? If we try and figure out what we can do with it, let's first try and kind of define it a little bit. I think this is off Wikipedia or something equally open source. You know, it's, you know, artificial intelligence is basically any intelligence demonstrated by machines, as opposed to natural intelligence as displayed by humans or other animals. Now, our CEO Anirudh tells a joke at these, which I'm shamelessly stealing about. You know, if I invented the if statement today, somebody would call it AI, and else would be reinforcement learning, right? So we have this tendency to sort of wash everything with AI. But what's more interesting, I think, is some of the actual applications of that we're referring to as AI, and how are they different than just the algorithms that we've developed as part of our industry and EDA in particular over the past, you know, so many years. I think one of the key things that we can understand is that AI can sometimes, and ChatGPT is a good example of this, the generation of artwork with this the generative adversarial network algorithms like we saw. This is actually a few years old now. Actually, it's more than a few. It's 5 years. This is from 2018 when this piece of artwork was sold, and that was the first kind of AI portrait, AI generated portrait that was sold and generated as art. And that's something that, you know, we now see where AI is starting to move into that area that we thought was reserved only for our level of the human level of sort of intuition and experience and intelligence. And it's important to understand, how can we leverage that, right? This is not just an if statement or an else, you know, an if else, right? This is something truly interesting. And that gives us this opportunity now in EDA to take the next jump, right? Over the last, you know, several decades, we've seen clearly EDA has gone from, you know, we're no longer laying out chips using, you know, a giant flat room and masking tape on the floor, right? We've moved well beyond that over the several years, and you know, when we automated transistor level design, and then automated cell-based design, and then automated RTL design and reuse, and now, you know, our next 10x, each one of those we saw something on the order of 10x improvement in productivity. And our next 10x, which is going to help address the massive complexity increase, the massive design start increase, and our shortage of engineering talent, is really most likely going to come from, or be primarily driven by AI. What can we practically use AI though for in engineering? One of the areas is probably improving the tool results, right? Can we use AI to build better tools and then build better results in tools? This is kind of almost the big red button approach, right? It's in there. We don't really know or care that it's in there. We just know that we're doing more intelligent, smarter things with the tools, and we're improving the tools results. Often I get the question, is this just going to replace all engineers? I was talking last night with some of my colleagues. I listened to a podcast on the way down here. I was in Cambridge yesterday, and driving down, I was listening to this podcast. I enjoyed it. It's a sort of general interest one called Stuff You Should Know. It's kind of a how to be boring at parties podcast, if you like. And they talk about all kinds of different things. You know, one of their episodes was just titled Coal, and another one was about you know, how to go dowsing or witching for water underground. So clearly just sort of general interest, kind of nerdy stuff. They talked about large language models in their most recent podcast. And most of the podcast was, oh my goodness, what's going to happen to all these jobs? Everybody's going to, you know, television writers are going to be replaced. You know, movie directors are going to be replaced. Artists are going to be replaced. Teachers are going to be replaced. And there's a lot of hysteria, I think, over, you know, just what can something like ChatGPT or AI in general do? And I don't think it's replaced all the engineers. Not in my lifetime anyway, that's for sure. At least not what I think. What I think we can do is catalyze the engineers, make the engineers more efficient, right? This is where we can start to leverage AI and machines in general for doing what the machines are good at, right? One of the challenges that humans have is that we're really not very good at data processing, or at least not large amounts of data. I mean, we can consume maybe 2, 3, 4 pieces of data at any one time. If you ask my wife, it's a lot fewer than that. But what machines are good at is doing something relatively simple to massive amounts of data, right? Massive parallel processing of different kinds of data. If we think of verification, think about how many log files you have, how many waveforms you have, how many pieces of RTL, any output of any EDA tool that you just ignore. It never gets used. It never gets utilized, whether it was generated a week ago or today or a month ago. We don't leverage all that, you know, if you think about failure analysis, how often do you look at the log files of tests that pass, right? And that's not because we don't think that there's good information. It's just we can't consume that much data. So these are areas that, you know, AI can potentially help us leverage that and catalyze us as engineers, make us more productive. I wanted to give an example because another question I often get is, well, what are we doing? You know, what is verification or EDA doing compared to what, let's say, the software industry? What's the state of the art in the software industry? And I had the pleasure of speaking about a month ago, maybe 2 months ago, to the founders of a company called Launchable. And Launchable has the goal of utilizing ML to intelligently select test ordering based on code changes. And their little tagline is, keep your developers happy with intelligent test selection to reduce idle time. Effectively, they're just trying to pick out, based on what code gets checked in, can we move certain tests to the front of the regression so that they're more likely to fail earlier and faster. And they have some results here that they claim, you know, some sort of reduction in test execution time and build time. And they said this is coming from an unnamed German car company they're working with, which is interesting. Now, I gave this some significant credibility because these founders are the same people that started the Jenkins continuous integration platform. They also worked at CloudBees and did some other stuff. And by no means am I endorsing them or think anything that works, but I wanted to know what is the state of the art in the software, and you know, can we learn something from that? One thing I did learn from talking to them is that they think sort of the same thing, that they had the same kind of vision that we do. You know, AI is not a replacement for human testers or human verification engineers. It should be used as a tool to augment their abilities, and this is from one of their co-founders, Mr. Singh. Which again, so that you know, this is you know, the software industry, the software world aligning, agreeing that this is the way, you know, kind of the way forward. Now that being said, software testing and verification is not the same thing, right? Because if you look in the upper left, upper right hand corner for you guys, my left obviously. They're still putting blogs on their website saying things, I don't know if I have saying things like, what is regression testing? And that's from May of this year. So clearly, you know, there are certain ways that software testing is still not what verification, IC verification is, or pre-silicon verification is. So I mentioned about, you know, what can we use AI for and how can we leverage AI to comb through all that data? If we think about, you know, to the next level of detail, I think this, you know, picture like this is probably pretty familiar, right? EDA has historically done a very good job of focusing on any one of these boxes, right? We make the emulation platform a little bit faster. We make the simulation run a little bit better. We make the formal tool more applicable, more greater capacity, better, more properties it can solve, and so on. But the reality is that you as verification engineers are using those tools day by day, week by week, and not running just one of those tools, but running each of those tools many, many times. And so what we need to do is figure out how to apply, or one of the opportunities is how do we apply AI to leverage the fact that there are multiple engines involved in the verification flow, but also multiple runs of every tool, right? We don't just run the simulator once, see what it does, and stop. We run it day by day, you know, hundreds or thousands or millions of times every day. And so in leveraging some of that, we see some AI opportunities in a number of sort of practical different places. One of them is for things like failure triage. You know, we are running hundreds, thousands, millions of tests, and we're getting, as we go search for those bugs, where you know, Francois, a little picture of a verification engineer was saying, I'm going to find that bug, I'm going to make it fail, I'm going to figure out a way to get, I know it's in there. Well, sometimes we're very, very good at making tests fail. We get thousands of them to go triage. And what we see is that as an opportunity to leverage machine learning to do some prediction about, well, what underlying root cause is common to a particular set of failures. Again, if you have 100 or even 1,000 failing tests, you don't have the capacity to go debug all those thousands. So what engineers typically do is some sort of level of intuition, some sort of leverage their experience to say, these you know, 100 failures all look like they're probably the same root cause, so I'll bucket them together, these 100, and so on and so forth. Well, we think we can use machine learning to do some of that by building a model that can predict which of those tests belong in which groups. We can do things like unsupervised or even supervised learning, some human in the loop, where the goal is not to, with 100% certainty, bucketize all of these failures, but rather, can we get to some high 90s percentage of accuracy where we're bucketizing these failures together so that engineers are no longer spending 2 hours or 3 hours or however long you might spend at the end of every regression doing this bucketization, but instead an engineer can simply qualify or quantify this at the end, after, you know, in say 5 or 10 or 15 minutes after the AI or the ML has come in and already made a bunch of predictions. We think there's an AI opportunity in regression debug as well. This idea that something passed yesterday, and now it's failing today or last week or last month or whenever something might have previously failed. And typically, that flow looks something like this, where some team of engineers is making a bunch of changes to a design, adding new features, fixing bugs, whatever it might be, running a regression. And then once something fails, again, we don't really consider any of the stuff that passed. We don't really consider whatever might happen yesterday. What we have is one or more people digging in and grinding away at waveforms. Now, EDA, we're working on better and better tools for waveform analysis and debug all the time to make this poor chap look slightly less frustrated and angry. But the reality is that you're starting at an error message and you say, okay, I'm going to grind away on these waveforms until I get to what I think is a root cause. And what we see is the ability, what we think is an opportunity to apply AI to that. Not, again, to solve them. So we're not replacing that engineer, right? We're not automatically going all the way to the end result. This isn't the big red button, just find me the automated solution. But we're catalyzing the engineer by giving them things like, giving them a kind of an AI assist. So for example, performing analysis, module XYZ has the greatest change from last week to today, right? Can we actually come out and do some analysis at that level? Commit to file foo.sv could be problematic. Could we look at those? Could we do some sort of behavioral analysis, right? We know, for example, and in some of the work that we've been doing at Cadence, that there's some behavioral stuff that we can pull out of the revision control very simply. Again, very difficult to analyze as a human, but we can look at things like, statistically speaking, check-ins made at 5 p.m. on a Friday, 5 p.m. on a Thursday if you live in Israel, are more likely to be buggy than those made at noon on a Tuesday. Now, it's not highly correlated, it's somewhat loosely correlated, but we include that with things like people who make their check-in for the first time are more likely to check in a bug at that time than an engineer making their 1,000th check-in. If there's a file that's touched by 100 different people, it's more likely to have a bug in it than a file that's only ever touched by one engineer. Those kinds of things, again, very difficult for a human intuition. When I say that out loud to you, you go, yeah, that makes sense. That probably is the case. But to be able to actually go and apply that is challenging because it's a lot of data. This is an area where we can use AI and ML. We can start to build a bug prediction algorithm to figure out, well, what constitutes a lot of change? What constitutes a problematic check-in? What constitutes a good place to start the debugging? Can we help you prove that most of the rest of your design is still working just as well as it was last week when this test passed, but some small portion of the design maybe isn't working as well? We think there's an AI opportunity for workload optimization. Can we use some of that same capability that we use for debug, like here's part of the design that changed a lot, to help you decide which tests to run? Do we need to run all whatever 10,000 tests you have, or do we know that a decoder or an interface or an ALU or whatever is the part that actually changed, and we can potentially target what tests or even synthesize new tests might go to better verify that change. There's probably I shouldn't say probably, there definitely is an AI opportunity for resource optimization. I would imagine that almost all of you are either, if you're not leveraging the cloud already, you're thinking about how to leverage the cloud. Well, the cloud versus on-prem compute offers really interesting opportunity and a really interesting challenge. When do you use the cloud? What do you request from the cloud? What resources do you use on-prem and what resources do you need in the cloud? How can you optimize your CapEx and OpEx spend for building new on-prem and building in the cloud? Well, if we can do things like start to predict, looking at a test suite, what are the memory requirements? How long are they going to run for? How many cores do we need? And then look at the resources we have and predict the availability. When's the farm in Sweden going to be overloaded versus when's the farm in the US or in Asia going to be overloaded? Where's the right resources to take advantage of? Something else that's come up recently is, of course, the difference between on-demand and spot instance in the cloud, right? This concept, spot instance, where yes, you get some compute resource at a vastly reduced rate, but you may lose that resource at any time if somebody else comes in and decides to pay more for it, right? The ultimate in capitalistic democracy, I guess. But can we predict how long we're going to have that spot instance for? Can we predict, okay, if it's, should we use the cloud resources that are available to us in Asia versus North America versus Europe at certain times of the day for certain things? Will we be more likely to get longer jobs and run on spot and so on and so forth? And if we can start to predict those things, we can start to build, ML models or AI models to help predict those, we can start to make better decisions so that we get higher yield, we get we get higher yield in terms of the jobs running in Spot, but overall, improved throughput and improved costs at the end of the day. This is something we talked about, and I believe that there's some more presentation this afternoon about large language models, right? What can we do with ChatGPT and its similar underlying technologies, the large language models, right? Is there an opportunity to do, for example, design spec analysis or even RTL analysis to help us understand, what's the quality of the RTL we've created? What is the quality of the spec we've written? What's the verification content? Based on this spec or this RTL we've written, should we have 1,000 assertions or 100 assertions? Or should we have 10 cover groups or 100 cover groups? What's the level of effort that we expect? And then maybe even get to the point of generating things like verification plans and even generating some content, right? Can we do that? And at what level can we do this? Is it going to be suggestive? Is it going to be, is it going to be 100% accurate? Probably not. It's most likely going to be catalyzing the engineer, right? Giving the engineer the hint to say, here's the outline of the verification plan we think based on this specification or based on this RTL you've written, and so on and so forth. A plug for where I've recently, you can tell from my accent that I did not grow up in Cork and in Ireland where we are now, but this is some of the kinds of research that we're doing there. Speaking of which, all of the new grads, if you're interested in this kind of thing, this is what we're trying to do. And actually, Nick from our office in Ireland is working on this exact type of technology. So if this is interesting, find him during the break and bend his ear. I know Nick. Those of you that know Nick know he likes to talk to anybody and everybody. So practical AI and verification today. What are we doing? In the last 5 minutes, what have we been able to actually accomplish, at least at Cadence, in terms of some of the stuff that I mentioned? Well, we have been able to improve tool results. We haven't figured out how to replace all the engineers yet. And we have seen some ways to make the engineers more efficient. Our Excellium ML, so Excellium is our logic simulator. We've released a machine learning app for that, where based on training, after some number of regressions, of some relatively small number, we can see as much as 5x improvements in coverage closure. So the ability to say, okay, I can, I was able to get to 95% coverage. I can get back to 95% coverage 5 times faster while maintaining randomization in the regression. So you're still hunting for bugs, but achieving what you've already achieved, what you can get, can be as much as 5 times faster. You can see some of the examples there from our early customer adoption of that. You can also see that, you get a similar kind of, here's our 5x improvement, right? From 10,000 CPU hours down to 2,000 CPU hours. And not only are you getting sort of, similar kind of results, but you're getting some improved density as well. Last year, we announced something we call the Verisium AI-driven verification platform. And the goal here is, doing some of those things I mentioned before, like leveraging AI on log files to do triaging. Leveraging AI on source code and revision control to help predict and rank the check-ins and run our little app called Pin Down. Running AI on waveform dumping to see, help to get to the closest to the root cause as possible. And then some other things that we've improved around that as part of that infrastructure. One thing interesting that we're finding out about AI and EDA is that it's not about, oh, let's find a better ChatGPT version, let's find a better algorithm for AI. It's really about being data scientists and looking at all the data we have and sort of organizing and conditioning that data and then applying, I wouldn't say a little bit of AI, but some amount of AI on top of that data to do something interesting. So it really is, at the application of AI, not finding better ways to do AI necessarily. There's lots of that out in the world. And that's actually one of the reasons that we see this opportunity is there is, the ability to get hold of some of these algorithms like ChatGPT and its, and large language models and like things like gradient boosting and other kinds of machine learning capabilities. The availability of those is so great that we can now, I wouldn't say easily, but we can, in a relatively straightforward way, apply that to various different things. And you can see some of the results we're seeing there, right? I mean, I don't know that on every single case we're going to see 30x improvement in debug, but we literally are at some customers saying, look, what used to take us, 6, 7, 8 hours is now taking us minutes to go do because we're able to the AI is able to do things like filter out all of it. So first of all, consider a large amount of data and use that large amount of data to filter out a lot of noise and get us back, to the exact point where we're, or get us very close to the point so that the engineer can then apply their intuition, their experience, and their knowledge and get that sort of last mile very quickly. Because, as we've seen with self-driving cars, the last mile is very, very challenging, right? So full automation is going to be very, very, very difficult. So in summary, right on time, complexity will continue to increase, which is obvious. Time to market will continue to decrease. Available engineering talent. The AI to fix my hands waving around. There we go. Did we break it? No? No, we're good. All right. The availability of AI to provides an opportunity for application and verification in many different ways. And what it really is giving us today is the ability to catalyze rather than replace the engineer, right? Make that engineer more effective more quickly. There's actually a study that I didn't quote. You go search up in Bloomberg. There was an article not too long ago, less than a month, but a study that was done by Stanford and MIT, where they applied kind of AI in various ways to some high-tech workers at wasn't really not a call center, but sort of a engineering response kind of a failure triage type of activity. And they found that overall productivity increased by 14%. But what was maybe more interesting is that the junior engineers, or the people with less experience, not only experienced an increase in productivity of somewhere between 30 and 40%, but ramped up faster. So AI can not only help catalyze the engineer in sort of the day-to-day, but help them grow their intuition, their experience that much faster. And in the end, we really think that we do see, and this isn't just me stating this, we've actually had public endorsement from both Renesas and Samsung recently that said this order of magnitude increase, thanks to AI, is something that they see a clear path to as well. So I think it's obviously very interesting. Hopefully we've answered the question of, I don't know what AI will do, but it might do something. I think it's not replacing all the engineers. It is absolutely catalyzing and hopefully making us all productive and making it exciting enough to, Francois' point, to lure more engineers into our area. So thank you very much. Q&A.
We've got time for one or two questions. Is that a hand up, Mandy?
Uh-oh, I'm in trouble now if Andy's asking a question.
I think you'll like this one. So I think it's going to be a big thing. It's going to be a massive production thing. Is this going to be engineering's Moneyball moment when suddenly everyone is ranked in the company about how effectively they add to a project, and you can see immediately who adds impact and who doesn't on projects?
So that's an excellent question, and I don't know. I don't think so. What I think will happen, and what the study that I referenced showed, is that it tends to bring the floor up. So first of all, I mean, the reality is we have a stack rank of engineers, right? Not everybody's the best and not everybody's the worst, but there is that ranking. But what AI has the opportunity to do is bring the floor up so that everybody is closer to the best engineer. And that best, most experienced engineer is now, I heard somebody use the word emancipated the other day, which I thought was a great word. That top engineer is now emancipated to go off and do other things, other interesting, architecture, whatever. That most senior engineer is not constantly answering the question of, oh, I've got this really tough question, I see this debug message, I don't, where should I start, that kind of thing. Maybe the AI can help with that. Now, and I'll add one other corollary to that. I was actually at a customer about maybe a month or so ago, and they had that same question. Oh, is this going to give us insight into who inserts all the bugs to our chip? And they thought for a second, then they turned to me and went, yeah, we already know who already inserts all the bugs. That was a good question. You're right. Thank you, man. Yeah.
So thank you for this. It was pretty engaging. You've touched on the topic of LLMs and data science. One of the things that we would see is security of your corpus data coming into public world. We've seen that with Samsung.
Yep.
How do you get to use such pre-trained models in verification without having to give out your corpus data into public world?
Yeah, it's a good question. So one of the things that at least at Cadence, we've determined that we need to focus on is the ability to come to the customer with a model that is somewhat pre-trained, on either stuff that's in the open source or stuff that we have access to, but also has the ability to train quickly. Now, one of the problems that the launchable example that I gave is when I talked to them, I said, oh, so you train on your customer's data. They said, yeah. So how long before you get good results? They said, oh, we train for about 6 months. And then we start to get good results. Well, most of your projects that you're working on are probably not that much longer than 6 months. So we can't really train on that and then expect good results. So we have to come with some, I guess, rapid training, if you like. The other thing is that we absolutely do need to worry about data security, and we can't just go and say, well, we're going to train on everybody's data everywhere, right? We have to come with a relatively dumb model that needs to train internally and then not send that externally. One of the things that LLMs is challenging with right now, like the example I'll give is images, right? Everybody's seen the memes that go around about, I asked ChatGPT to show me, Brad Pitt riding a camel in downtown New York, and it comes up with an image that shows that, or something ridiculous. Well, Getty Images, right, which and similar companies are now saying, well, wait a second, you used 3 Getty images to composite those together. You didn't transform them. So it's not transformative like if a human actually goes and Photoshop stuff together, that human owns that. But since it's 3 images that are composite that was just done by AI, that's not transformative. That's, we still own the copyright for that, even though it's not, our original image. So there is that challenge with large language models. How do we get around that? And there's a little bit of I don't know. I know at Cadence, not long after the Samsung thing came out, we got a big thing from legal. Stop all work on LLMs. We don't do this anymore. And now we're figuring out how to wind that back, right? And like, okay, well, how do we do this in a way that we don't infringe on copyright and we don't, end up publishing our customers' data and all that kind of thing, but still deliver some of the value that we think exists there. So it's definitely going to be a challenge for sure. And TBD, I guess, was not 100% sure. Yeah.
Okay, brilliant. Thanks, Matt. I think it's time for break now and let everyone get refreshed. Just as a reminder, at 11:30 we go into different tracks. This is the room for formal verification. If you want VHDL verification, you go to room 1 and 2, and they're at the other side of the screen, up that end. And Doulos are going to be doing that introduction to SV in room 05. Okay, it's advertised to students, and we encourage the students to go, but you can also go if you want to learn about that SV. Okay, thank you to our speakers this morning, and hopefully get yourself refreshed, and we'll see you again at 11:30. Thank you.